Is my screen visible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir, visible.
Okay. Actually, last time I discussed half adder. I think you people can remember half adder. Half adder is nothing but 2-bit adder. That means I'm recalling the lesson a little bit, otherwise sometimes it is difficult. 2-bit adder, A and B, let's say these two are the bits, and at the receiver end or at the output side, we get sum and carry, and we also derived the expression for sum and carry using logic gates. Okay. Now we'll discuss full adder. Full adder is nothing but initially we have some here actually we'll have 3 bits A, B, and C. Okay, this is called 3-bit adder. Okay, actually in addition sometimes we have the carry of first stage added in carry of second stage like that. So that's why we require this type of error. Here we also have sum and carry, but expressions are different depending on the operations required. Because in decimal addition also we add 2 digits and then we have carry here, and then we add 2 digits and we have to add its carry also. That is coming from this side. So in this way actually we do addition. So same thing we do it for binary operations, but in full adder we have to do this. Okay. Is someone trying to enter? Now, how do we get the expression and how do we find it? Okay. For the time being, I'm erasing that part. Okay. If required, I will erase. Otherwise, we keep on doing so. So, since there are 3 bits, okay. So each can be 0 and 1, 0 and 1, 0 and 1. Now, as a result, how many permutations do you expect at the input side?
8, sir.
It is 2 because we have two options here, then 2, then 2. Then it is 2 to the power 3 or 8. Okay. Now let us check its truth table, or let us construct its truth table, better to say A, B, and C, and at the output side we have sum and carry. Okay. Now we generate the combination. As I have mentioned that it is a shortcut rule that since it is 8, we divide it into two half, 4. So 4 zeros we have to write first, and then 4 1. Then further divide 4 by 2, 2 0, 2 1. Then again 2 0, 2 1, and divide 2 by 2, then 1 0, 1 1. That means 0 1, 0 1, 0 1. In this way, actually we generate permutation. Okay. But it's not usually called permutation.
Sir, can you repeat, sir, how you said generate the combination?
How do we generate the combination? Actually, since total number of combinations may be 8, okay, input combinations. Here from the analysis we find. Now, 8 so divide 8 by 2, that means 4. So there will be 4 0 and 4 1. This is shortcut actually. This is not very conventional. Then in next, for next input, divide 4 by 2, then 2, 2 0, 2 1, 2 0, 2 1. And then for next input, divide 2 by 2, that is, sorry, this one. Then 0, 1, 0, 1, 0, 1, 0, 1. In this way. Okay. If it is 16, that means there are 4 input combinations. So first we have to write in a 0, 8 zeros at a stretch vertically, then 8 ones, then 4 zeros, 4 1, then 2 zeros, 2 1 in this way actually. So this is
Okay, sir,
what
understood.
either you can also generate by binary conversion, because if you notice that this is decimal 0, 0 0 0, this is decimal 1, this is 2, this is 3, this is 4, 5, 6 and 7. So actually these numbers are from 0 to 7. Okay, so if you directly convert 0 to 7 into binary, 3-bit binary, then you can also get this combination. Okay, so in either ways you can get. Actually, this is the procedure, but by shortcut, when we need to quickly generate this combination, we use this convention. But actually, this is the procedure. You have to encode 0, then 1, then 2, then 3. Now, what is the sum? Actually, when 3 digits are added, okay, sum is 0, carry is 0. If you have some problem with it, then you add in this way, okay. Sum is 0 and there is no possibility of carry. 0, 0 and 1. Sum is 1, carry is 0. Any doubt?
No, sir, understood.
No, okay. Then 0, 0, 1, then, sorry, actually, this is my mistake. I had not properly divided the line, that's why. This is my mistake, not your mistake. Otherwise, it can create confusion. Okay, I think it is quite okay. Now 0 1 0, this is also 1, this is 0. You can do it by yourself. Now 0 1 1, actually it is nothing but 1 plus 1. So if it is 1 plus 1, then sum is 0, carry is 1, and in next step also we do 1 plus 0 because it is carry. So actually sum is 0 and carry is 1. Okay.
Sir,
Here
can
sum
you
is
repeat
1, carry is
how you have done this sum and carry?
okay. 0, 1 and 1. This is something you have to do. Now, if it is 2-bit addition, then after this, what do you get? Sum 0 and carry 1. Okay, sum 0 and carry 1. And now this carry is added with this one. Okay, to get the final carry. So you will understand it actually. This is your carry and this is your sum. That means when you do 1 plus 1, if it is 2-bit addition, what is the outcome? Sum is 0, carry is 1.
It is OR operator or normal arithmetic sum.
This is normal arithmetic. There is no such Boolean logical operator is there. When we convert it into logical expression, then for implementation there will be logical operation. But this is normal addition. 1 plus 1 addition. In binary mode, it cannot be 2. So it is sum equal to 0, carry equal to 1. I think you consult the 2-bit addition first, then you will understand it much better. So you try to notice similarly, if there are 2 ones actually, 2 ones, then sum should be 0 and carry should be 1, because if we do this addition 1 plus 1, then sum is 0, carry is 1, and now we are again adding 0 with it. So okay, there is, I think there is some problem with the explanation. 1 plus 1, if it is 2-bit, then 0, then 1, and now we are adding 1. Sorry, there is one more 0. Then we have to add. Actually, I had added with carry. That is the root of the confusion. Now it is final sum, and this is the carry. I think it will be much better to understand. Because this addition does not produce any sum nor any carry. That's why there is no such update in final sum and carry. Okay. But this addition does. So you will do it, you can understand. Same thing happens also here. It will be sum is 0, carry is 1. Sum is 0, carry is 1. And in this way, actually, we will have sum 1 and carry 1. Why is it so? Because 1 plus 1, if we do sum operation, sum is 0, carry is 1. Then if we do again plus 1, so that one should be added with this. So sum becomes 1 and carry becomes 1. Understood or not?
Understood, sir.
Okay. See, you just check every entries in this way. So you can proceed. You can understand that. Is there any problem with any of the entries? So you can also tell me. Same thing. Let's say if I take that 5, number 5, 1, 0, and 1. Actually, what I had done earlier, that is, I had added the extra bit with the carry. That is the root of all confusion. Okay, that's why I am asking you to follow this technique or this concept. Okay, so when we are adding 0 and 1, sum is 1, carry is 0. Now we are adding 1 again. So after that addition, sum should be 0 and carry should be 1 because 1 plus 1 means 0 and 1 carry, so it becomes 1. So it is 0 and 1. Any doubt? Check it. If you have any doubt, then clarify. Let us clarify. If you don't have any doubt, then we will go for logic synthesis. Any problem with the table? Please check it. Any entry that you haven't understood or anything? Actually, these are inputs and these are outputs. No, have you understood the complete table? Yes or no? Tell me.
Yes, sir.
Yes, sir. Okay. That's very comforting. Okay. Now we have to find the output expression for the outputs. Sum is one of the outputs and carry is another output. Okay. Now how to get the expression for sum? So let us identify the ones. This row, and this row and this row for sum. Okay. Now what I had shown earlier that when it is 0, then you have to consider the complement of it or inversion not operation of it. Now we are switching over to logic gate. Okay. I think in last class I had shown that thing. Okay. So this is A complement, this row. For B complement, I am doing it very slowly such that you can understand it properly. Still, if you have any problem, please tell me. For this row, A complement, B, C complement. For this row, A, B complement, C complement. For this row, A, B, C. Okay. Now we are joining by OR operation. This is the expression for sum. Understood or not? Now, if you simplify, you can also find it in different ways. In exclusive or it you can be used to represent it. But I'm not getting into that kind of simplification or minimization. So I'm sticking to if I can produce the output expression or not. Okay. If I can produce the output expression, that's okay. Is there any doubt to understand this? If there is any mistake or anything that you haven't understood or like that, you can tell me. Okay. Understood or not?
Yes, sir.
Okay. Is it then carry? Please feel free to ask me if you haven't understood it. Okay. Removing these check marks. Now we have to place check marks. This is carry. Carry equal to 1. For this, carry equal to 1. For this, carry equal to 1. For this, carry equal to 1. Now, similarly, we have to find the variables. It is A complement B C. A B complement C. This is A B C complement. And that means not operation. Complement means is not operation. And this is A, B, and C. So if you realize this using logic gates, you can do this, no problem. I'm not getting into that detail because it requires lots of wiring, lots of gates. I think you can do this. If you are asked to use two input and an OR gate, then it is little bit clumsy. But in exam, this is the most usual question that you are asked to use two input gates. Okay. Except for the NOT gate, because NOT gate cannot be two input. Because for three input gates, it will be much easier. But if you have to realize the same thing using two input gates, then it is little bit difficult. Okay. So understood? Can you do it using two input gate? Is it possible or not?
Yes, sir.
Okay. I think I am not implementing the gate because okay, let us do it because it may sometimes be very confusing. So let us do it. These are the input lines. This is A complement, B complement, and C. So and this is joined by AND. So if it is two input gate, then you have to use in this way. Okay. So this is nothing but C. Okay. Now A complement, B, C complement.
Sir,
Hmm?
sir, can't we use three in one single AND gate?
That is if nothing is specified, you can do this. But in most of the exams, it is written that use two input gates. Okay, but if it is, then it is very easy. You can directly join. There will be single one AND gate, and you feed these three inputs line.
Okay, sir.
That is very easy. But if nothing is specified, you can do this. No problem. A complement, B, C complement. A bar, B, C bar. Uh, so this is A bar, B, C bar. It is the second component of the sum. This is A bar, B, C bar. Okay. Next, A, B bar, C bar. A, B bar, that is incorrect. That is incorrect. ABC. Now, if you are asked to join using two input OR gate, then you cannot join at a time. You have to join either 2 by 2. This is the expression for sum. You can similarly do it for carry. No problem. Any doubt to understand this?
No, sir.
Okay. One thing you should keep in your mind that when you use the same expression using 3 input gate and 2 input gate, what is the difference? Let's say this is we are using 3 gate, same thing. We are supplying using 3. Actually, we are using a type of gate that accepts 3 inputs, and we are using a kind of gate that accepts 2 inputs. So what is the difference in both of the scenarios? Here each gate, when a signal passes through a gate, it generates a delay, some amount of delay. So let's say this delay is D here. Capital D, let's say. So here actually D, and here it is D. So actually up at the when final input is generated, output is generated, it suffers the twice of the delay what is happening here actually compared to this situation. I think you can understand what is the meaning by it, because each circuit generates some delay or introduces some delay on it when it passes through some electronic component. So when you use two input gets more, or the gates with fewer number of inputs, your system will be a little bit slower, because there is more chance of delay being introduced by the system. Here also there is delay, but that amount is very less. And another thing you may consider that here I have used a complete A bar, B bar, C. Here I have used A bar, B bar, C. So can we not draw this line directly here? This will definitely save this inverter, okay, because that is also creating some delay. Not only that, each gate has some material cost or like that. So with less number of gates, this thing can also be prepared. Okay. There are lots of areas where we can optimize gate realization. So I am not getting into that issue because it requires the concept of K mapping and other types of minimization concept. Okay. So up to this, I think if you can learn properly, it will be enough for your syllabus. So for binary system, let me summarize what we have learned so far. So number system conversion, that actually we have learned variety of topics, number systems and conversion among the number systems, and then we have learned um, signed and unsigned binary. Within this, there are some issues like one's complement, two's complement, representation, this type of things. And not only that, then we have to learn logic gates and some applications of logic gates like full adder, half adder, this type of things. Adders, circuits, this type of thing. So this is up to, I think this is enough for your syllabus. Next, we'll move on to function. As per the opinion of some people, functions should be taught earlier before the other syntax like loop, decision control, because function is the fundamental aspect of C programming, because this programming style is function oriented. Yes. If you have any question. Actually, C program can also be thought of a collection of functions. Like we know one of them, main is one of the functions. And from main function, actually the execution begins. Other than main, we know some functions like printf, scalar. I think pow function I have also already used. So for these are nothing but the function. So what function is, actually we have to know. Function is a self-contained block. There is a is there any problem? Easy. This one. Okay. Self-contained block of statements that executes, sorry, spelling mistake. So roughly we can characterize function in this way: a self-contained block of statement that executes a well-defined task in main. So for whatever we have written inside main, so main does some well-defined tasks such as factorial calculation, such as any other type, decision making, percentage calculation, providing grade or like that. So, uh, but sometimes your job is very complicated, so you cannot keep it inside main. So in C programming it is, and if you it's not very true to say that we cannot do all sort of things inside main, but rather it will be a little bit uh, clumsy type of design. So that's why we abandon this type of habit of writing all sort of functionalities or writing all sort of computations inside main tab. If we have the scope to divide it into some units, we divide it and develop